Okay, so this lecture is meant to just give you the basic framework for how to solve a compound circuit problem. So we've just come off of looking at how to even figure out the total resistance of a circuit, and we just kind of introduced the idea of how to find a total current, and now we're going to look at the idea of, okay, what do I do with that information at this point? So our first step is going to be, we've already kind of done this, we've learned this. The first step in solving any compound circuit problem is determine the total resistance of the circuit. And so we've had some practice doing that already. Write a little meter. And then second step is determine the total current that's coming out of the power supply. And so for those that are a little bit more of a visual learner, this would be implementing Ohm's law with my total subscripts. Okay, so this would be saying, okay, I total is equal to my V total, my R total, and we just found R total in that first step. Okay, now my third step is determine which of the resistors is going to get the total current from the power supply. So determine which of the resistors will get I total. Okay? And usually these are in series with the power supply. So either they are at the very beginning of the circuit, at the very end of the circuit, but it's essentially like they're coming right out of the path of the power supply, or they're going right into the path of the power supply. So determine which of these resistors will get I total, and these are in series circuit. And from there, if you know the current, determine their voltage. So determine the voltage consumed in those resistors. And again, you're going to use Ohm's law, but this time we'll rearrange it a little bit in that if I bring the R over, you could say that V is equal to IR. And this, I've got this bookshelf in the way. This is going to be for an individual resistor, okay? Now the next part's a little abstract and it may not make sense until I come back to class with actually practicing problems. But step number 4 is determine how much voltage is left for the other resistors to consume. And remember the idea of conservation of energy. I'm going to start with some total voltage, and then, I want to do an equal. I'm going to start with some total voltage, and then I'm going to lose some voltage to other resistors. So it may be that I'm subtracting 1 or 2 or how many ever. Okay, and this is very case specific. So this is not a one all be all. This is, well, what does it look like for this particular circuit? Okay. And then the last step from here is once you know the voltage for those resistors, you can find the current. So knowing the voltage of these other resistors, find the current through them. And so we're going to go back to Ohm's law. So right now, this probably seems pretty abstract. You're like, okay, I wrote that down, but I don't know what that means. But when we get back into class, we're going to use this as like our framework for tackling all these problems. And I'm going to show you a method to kind of help organize this and to kind of make sure we're hitting every step. We'll do this in a table. But this will just allow us to, when you get back into class, we can just hit the ground running and apply this to several examples, okay?